So, welcome to Unit 2 live session. Wanted to do this last night, but I lost my internet connection. Came back this morning, my time. But anyway, this week we are taking a look at exceptions in advanced file I/O, and also looking at from chapter 11, exceptions in advanced file I/O, and from chapter 12, initial look at graphical user interface. So let's get started with this. Okay, so we're going to be discussing handling exceptions, throwing exceptions, more about input-output streams, advanced topics such as binary files, random access files, and object serialization. So handling exceptions. An exception is an object that is generated as the result of an error or an unexpected event. Exceptions are said to have been thrown. It is the programmer's responsibility to write code that detects and handles exceptions. Unhandled exceptions will crash a program. Java allows you to create exception handlers. So an exception handler is a section of code that gracefully responds to exceptions. The process of intercepting and responding to exceptions is called exception handling. The default exception handler deals with unhandled exceptions. The default exception handler prints an error message and crashes the program. Okay. So exception classes are classes that are derived from an error message. Applications should not try to handle these errors because they are the results of serious conditions. Programmers should handle the exceptions that are an instance of classes that are derived from the exception class. Example of exception class. This is an example of handling exceptions. And the way you do that is you use a try statement. A try block is one or more statements that are executed and can potentially throw an exception. The application will not halt if the try block throws an exception. After the try block, a catch clause appears. This is an example of code that's designed to handle a file not found exception if it is thrown. And a good point is that the Java virtual machine searches for a catch clause that can deal with the exception. Handling exceptions, perimeter must be of a type that is compatible with the thrown exception type. After an exception, the program will continue execution at the point just past the catch block. Each exception object has a method named getMessage. So polymorphic references to exceptions. When handling exceptions, you can use a polymorphic reference as a perimeter in the catch clause. Most exceptions are derived from the exception class. A catch clause that uses a perimeter variable of the exception type is capable of catching any exception that is derived from the exception class. This is an example of a polymorphic reference to exceptions. Now, how do you handle multiple exceptions? Well, the code in the try block may be capable of throwing more than one type of exception. A catch clause needs to be written for each type of exception that could potentially be thrown. And the catch clause must be listed from most specific to most general. And there can be polymorphic catch clauses. The finally clause, the try statement may have an optional finally clause. If present, the finally clause must appear after all of the catch clauses. The finally block is one or more statements that are always executed after the try block has executed and after any catch blocks have executed if an exception was thrown. The statements in the finally block execute whether an exception occurs or not. The stack trace, the call stack is an internal list of all the methods that are currently executing. A stack trace is a list of all the methods in the call stack. It indicates the method was executing when an exception occurred and all the methods that were called in order to execute that method. Here's an example of a stack trace. Uncalled exceptions. When an exception is thrown, it cannot be ignored. It must be handled by the program or by default, the exception handler. When the code in a method throws an exception, normal execution of that method stops and the JVM searches for a compatible exception handler inside the method. Uncalled exceptions. If there's no exception handler inside the method, control of the program is passed to the previous method. If that method has no exception handler, then control is passed again up the call stack. If a control reaches the main method must either handle the exception or the program is halted. There are two categories of exceptions, unchecked and checked. Unchecked exceptions are those that are derived from the error class or the runtime exception class. All exceptions that are not derived from error or runtime exception are checked exceptions. If the code in a method can throw a checked exception, the method must handle the exception or it must have a throws clause listed in the method handler or the method header. Examples of checked and unchecked exceptions. Keyword throws can be written at the end of the method header, followed by a list of the types of exceptions that the method can throw. The throw statement is used to manually throw an exception. So let me go back one. Creating exception classes. You can create your own exception class by deriving them from the exception class or one of its derived classes. So some examples of exceptions that can affect a bank account: negative starting balance, negative interest rate, negative numbers passed, negative numbers passed to the withdrawal method. The way binary files is the way data is stored in memory. It's sometimes called the raw binary format. Data can be stored in a file in its raw binary format. So how do we write and read strings? To write a string to a binary file, you use the data output stream class's write UTF method. How do you append data to binary files? You use the file output stream constructor takes an optional second argument, which must be a Boolean value. So sequential access, the first time data is read from the file, the data will be read from its beginning. As the reading continues, the file's read position advances sequentially through the file's contents. Sequential file access is useful in many circumstances. You can locate data buried deep inside, and it can take a long time. Java allows a program to perform random file access. It's an example. The file pointer. Object serialization. If an object contains other types of objects as fields, saving its contents can be complicated. Java allows you to serialize objects, which is a simpler way of saving objects to a file. So that's a little run through of exceptions in advanced file IOs. Now we're going to take a look at graphical user interfaces. So let's call up chapter 12, where we take a first look at graphical user interfaces applications. Okay. So in this chapter, we're going to discuss the following topics: creating windows, equipping GUI classes with a main method, layout managers, radio buttons and checkboxes, borders. We're going to focus on problem solving, extending classes from JPanel. Many Java applications use a graphical user interface called a GUI. Basically, a GUI is a graphical window or windows that provide interaction with the user. GUIs accept input from the keyboard or a mouse. A window in a GUI consists of components that present data to the user, allowing interaction with the application. This is just some examples of some GUIs: buttons, labels, text fields, checkboxes, radio buttons, combo boxes, and sliders. So in Java, you will utilize the Java Foundation classes to create GUI applications. It consists of several sets of classes, many of which are beyond the scope of this book. The two sets of JFC classes that we focus on are AWT and Swing classes. Java is equipped with a set of classes for drawing graphics and creating graphical user interfaces. These classes are part of the Abstract Window Toolkit, AWT. Went too far. That one, okay. So there's JFC, AWT, and Swing. So Java programs using AWT look consistent with other applications on the same system. The behavior of components across various operating systems can differ. Programmers cannot easily extend the AWT components. AWT components are commonly called heavyweight components. Swing was introduced with the release of Java 2, and it's a library of classes that provide an improved alternative for creating GUI applications and applets. Event-driven programming are programs that operate in a GUI environment must be event-driven. An event is an action that takes place within a program, such as the clicking of a button. Part of writing a GUI application is creating event listeners. An event listener is an object that automatically executes one of its methods when a specific event occurs. That's JavaX, Swing, and java.awt. Creating windows. Often applications need one or more windows with various components. A window is a container. It's like a box, which is simply a component that holds other components. A container that can be displayed as a window in a frame. In a Swing application, you create a frame from the JFrame class. And a frame is basically a border around it, title bar, and a set of buttons for minimizing, maximizing, and closing a window. These are standard features that are sometimes referred to as window decorations. That's just an example of a window. That's how you create a window. This is the following code that displays the window. The set visible method takes a Boolean argument, true, display the window, false, hide the window. This is about extending JFrame. So equipping GUI classes with a main method. Java applications always starts execution with a method named main. Applications can also be written with the main method directly written in the GUI class. Adding components, three fundamental components are JLabel, an area that displays text, JText field, an area in which the user may type a simple lineup to input from the keyboard, and a JButton, a button that can cause an action to occur when it's clicked. This is a sketch of a kilometer converter GUI. Adding components. A content pane is a container that is part of every JFrame object. Every component added to a JFrame must be added to its content pane. Content pane is not visible, and it does not have a border. A panel is also a container that can hold GUI components. This is talking about adding components, panels. Handling action events. An event is an action that takes place within a program, such as the clicking of a button. When an event takes place, the component that is responsible for the event creates an event object in memory. The component that generates the event object is known as the event source. Event listener is an object that responds to events, and they are specific to each application. As an example, this is an example of handling action events. This is color constraint constants. These are predefined constants you can use for colors. So an important part of designing a GUI application is determining the layout of the components. The term layout refers to the positioning and sizing of its components. A layout manager is an object that controls the position and size of components and makes adjustments when necessary. There's several layout managers: flow layout, border layout, grid layout. This is the flow layout manager. This is the border layout manager, where components can be placed. So how do you nest components in a layout? Adding components to panels and then nesting the panels inside the regions can overcome the single component limitation of layout regions. So you can achieve sophisticated layouts by adding buttons to the JPanel and then adding the JPanel object to a region. This is the grid layout manager. These talks about radio buttons. So the JRadio button class is used to create radio buttons. Talk about button groups. Radio button events. Checkboxes. Checkbox appears as a small box with a label appearing next to it. Like radio buttons, checkboxes may be selected or deselected at runtime. When a checkbox is selected, a small check mark appears inside the box. Basically what it is a checkbox. This is the checkbox class. It's how you determine selected checkboxes. This is about selecting checkboxes in code. This is about borders. How you can add borders to from the JComponent class. This is the Brandy's Bagel House application. Splash screens. Splash screen is a graphic image that is displayed while an application loads into memory and starts up, like your home page. So this week, like I said, we talked about from chapter 12. We took an initial look at graphical user interfaces from chapter 12, and from chapter 11, we looked at handling exceptions in advanced file IOs. So that concludes this week's live session. I hope you found it informative, and take a look at the slides that I presented. Provides you with some great information about exceptions in advanced file IOs and about graphical user interfaces. So hope everybody has a great weekend, and we'll talk to you next week.